Welcome back to Solving Problems Together. Today we're going to dive straight into a problem that has a geometric flavour. If you have any initial thoughts or ideas on how we might solve this that's different to what I go through, feel free to jump right in the comments and let us know what you're thinking. So, we're initially told that three rectangles are lined up horizontally as shown. They're all in a landscape orientation and we've been told their dimensions. The first rectangle has a height of 2 centimeters and a length of 4 centimeters. The second rectangle has a height which is 4 centimeters, and this time the length is 8 centimeters. And finally, the third rectangle, the largest of them, has a height of 8 centimeters and a length of 16 centimeters. So typically at this point I would label the diagram just so I've got all the information at hand. All of these lengths and dimensions may well come in useful. We're also told, and you can see in the illustration, that there's a straight line that joins the bottom left corner to the top right corner. And we need to try and find this green shaded area. So let's start with some initial thoughts. What first comes to mind that might be a good strategy to approach this problem? We're definitely working with area. So can I find the area of each of these individual green shapes and add them together? It looks like I've got a triangle and a couple of trapeziums. But I also see that some of these lengths, these ones on the trapeziums, I don't know what they are, and they might be a little bit tricky to find out. I might have to do some ratio work before I can find those out. Before I go down that road, I'm just trying to think if there's any other approaches I might be able to take. Okay, so actually, we are looking for area. Could I maybe find the area of this big triangle that I seem to have in the bottom right of the compound shape? And could I find the area of each of the rectangles, and then some subtraction hopefully will get me the green area we're looking for? Okay, I'm confident in that. I think I can get quite far with that initial approach. Okay, so let's start with the area of the three rectangles. Well, it's going to be the length times the width on each of these three. So we've got 2 times 4, I'm going to add on 4 times 8, and then I'm going to add on 8 times 16. So altogether, the area of the compound shape made from the 3 rectangles is 168 centimeters squared. Can I do a similar thing for the area of the triangle? So the white triangle I can see now has a base of 28 centimeters. If we add the bases of each of these rectangles together, then we get a triangle which has a base length of 28 centimeters and a height of 8 centimeters. The area of that triangle is half times the base times the height. In this case, 112 centimeters squared. To find the green shaded area, I can start with the area of the rectangles and subtract the area of the triangle. 168 subtract 112 gives us 56 centimeters squared. As a quick sense check to see if I have a sensible answer, I can see that the green portion in the 2 larger rectangles is less than half the area. So my answer of 53 centimeters squared out of a total 168 centimeters squared does seem sensible. Let's keep this conversation going in the comments, where you can contribute some of your initial thoughts on how you might have approached this problem. I'm sure there are other mathematical techniques that could have taken us to the same endpoint, so if you've got any of these in mind, share them below. And finally, some of my favourite comments come from the different ways in which we can take this problem further. What else could we have found out about this situation? What other stipulations could we have added to make this problem more challenging or interesting? Are those the same thing? But either way, come back soon for us to solve another problem together.